Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Hello everybody. In our presentation, our paper is under the title of Survivable by Connected Topology for Yemen's Optical Network. This is me, Omar Khalid Basalim, and other authors for this paper. This is the short introduction for the optical fiber. Actually, in the last 3 decades, the optical fiber has transformed the telecom landscape in the world by over some advantage like over low losses with high bandwidth and long lifespans. And also if we use some techniques like the WDM, wavelength division multiplexing, and some devices like repeaters, amplifier, we can get the best result for this network. Okay, this now the question, why bi-connected network? Actually, in the I have to mention here the optical fiber as the cable is not expensive, but the deployment for this cable is expensive, and there are some constraints, some complicated like right of way and other things. So the standard topologies like star, bus, ring maybe is not suitable because their topologies is not expensive, but also is not give us the high robustness, robustness for the network. And if we see the mesh topology is considered of the standard topology. Mesh topology, yes, the network it will be strong, but is very expensive. So here if we see the bi-connected network, we can reduce the cost by using bi-connected network, as well as we can get the high robustness for the network, because the bi-connected is under the condition of one-to-one path protection. This is the condition for bi-connected. That means each two node in the network, for example here we have A and A is connected by the path, and there are also the another path is like spare. If there are any problem in this path, these two nodes it will be still connected because by this path. Okay, here the problem statement. As I mentioned before, the deployment for the optical fiber is not cheap, is expensive, and also sometimes when we want to expand our network, the robustness for the network is reduced. We have to keep the network in high robustness, or at least in the minimum requirement for the survivability. Here the objective: to optimize the deployment of bi-connected optical network in terms of fiber deployment cost, to propose a suitable bi-connected network with minimum extra links that connect all governorate of Yemen. Significant of work. Actually, despite all benefits of optical network, but unfortunately there are some countries in emerging phases, especially the developing countries. So we hope this study create the real solution for these countries to use optical network by create the competition between service providers, and by solve the problem of limitation survivability problems. Okay, here we have the some works is related with our work. The first paper is under the title of optimal topology planning of optical network with respect of overall design cost. Actually, the authors in this paper is divide the total cost into three main bars. There are duct cost and fiber cost and switching cost, and also there are case study for this paper in United States, and the network is connected by an protected network, and one-to-one path protection and one-to-two path protection. If we see here one-to-one path protection, that's mean by connected, and here two-to-one path protection, that's mean each path between two nodes have the two spare paths. That's mean three connected. That what the second paper was enhance survivable topology, redesigning of optical band broadband network with by connectivity. Here we see there are two case studies. They were in Germany and America, and in both of them, the result of this study, in both of them, the cost is reduced to less than half by using bi-connected network. We have to mention here the three steps for the algorithm they use is similar to our approach, to our steps in our approach. The steps for them is was reduction, augmentation, and fine tuning reduction. Okay, here we have optimizing CRAN backhaul topologies. Actually, CRAN is cloud remote access network that we will see it in soon future because 5G is based on CRAN. Actually, CRAN is consists for two parts of networks. Is consist for wireless network and consist for optical network. In optical network, the authors is examine which one is more suitable to use, tree topology or bi-connected topology. As the result for this study, the bi-connected topology it was more suitable to use. Okay, here in the last paper for our related works, measuring and improving network robustness, Chilean case study. This case study it was in Chile. Actually, the geography of Chile is long and thin, so it's difficult to create the suitable network or national network for Chile. But by connected network, this paper is can overcome for this problem by use by connected network. We will see here this is the Reno network for the university in Chile have the same have the similar characteristics of Chilean geography map. So the result of this study is overcome for this problem. Okay, here Yemen's governorate map. We will see here we have 21 cities in Yemen. So we want to connect all of them by using by connected. Here we will see by complete graph. Each node, complete graph, each node is connected with all other nodes in the network. Is strong. The network is strong, but it's not practical because it's very expensive. Okay, here to obtain bi-connected we have two approach. Actually, the first one is integer linear programming ILB formulation. We will see here we have ILB variables and ILB constraints. There are some variables and some constraints and also objective and data by using Cplex. Cplex is optimization is an optimization software package. By using Cplex, we will get this. This is the output of ILB. Each node is connected with two nodes that have the shortest shortest distance. Okay. Okay, here I have to mention actually the first one, ILB is sometimes consumed a long time, and also we have to our device is have the high performance. This approach, which we called it heuristic approach, this approach is easier and faster. It's not complicated. It's easier and faster. This approach is constant two main phase. The first phase is give us two each connected, and then from each two connected by using between a centrality for each node, we can get the by connected network. Okay, and here we will see here to get the to each connected we will use also Cplex software, and to get here to get between centrality we will use MATLAB. So here we will see to get the to each connected, it will connect each node with two neighbors of shortest each length. If not come to each connected, the number of each will be extra by one, and so on, one to get to each connected. Then from each to each connected we will see how we can get by connected. The first step we get between centrality, then we divided this between these nodes in some groups based on its between centrality, and then from this we will add some extra node, some extra edge to get by connected network. Here we have the output for the two node connected. As I mentioned before, each node is connected by two nodes, but we will see some nodes we add by three. Here we will see node number 3 is connected by 3. One is referred to connected, 0 disconnected. We will see here this is node number 3 is connected by 3, and also we will see node number 8 is connected by 3. This is the result for the simplex. Here we will see the betweenness centrality for each node. We will see here node number 19, group A have the highest value for betweenness centrality, and these nodes have the lowest betweenness centrality with 0 value because it's in the edge, and this is in the center of the network. This is the bi-connected, our bi-connected. This what it's called all possible solution, because this is the normal bi-connected. Then we can improve our result by remove the extra, some of extra links. Here we will have after remove some extra links, we will get this is the bi-connected. Now if any fail for each node, the network still connected. Conclusion, as you see, we used bi-connected, and by using bi-connected topology we can reduce the cost, and at the same time we can meet the minimum requirement of survivability as well. And also by this approach we can get another topologies like tree connected and so on. Thank you so much. If you have any question, thank you so much.